Determine if a function is invertible, or if you can invert it, or if there's an inverse function for it. Okay, so I'm going to talk a little about what an inverse function really is. Okay, so I'm going to do both the graph version, what it looks like, and then just the straight up equation. Okay, so I'm going to first do the equation version. Let's say we have a function that's y equals 2x. Turn this lamp off. There you go. The inverse function of this, all you do is you switch the variables. So x equals 2y. Now we solve and make y by itself. We get y by itself by dividing both sides by 2. Now y is equal to x over 2. So the inverse function, you can also see it written as f of x negative 1. The inverse function of 2x is equal to x over 2. All right, let's do one more. I'm going to graph all of these guys in a second. Let's do y equals x squared. All right, the inverse, we switch the variables. X equals y squared. And now we're going to solve for y. So we square root both sides. That cancels off. We're left with y equals square root x. So I'm going to see here. It's okay. All right. We're good. So ignore this stuff. So function y equals 2x. The inverse is x over 2. Function y equals x squared. The inverse is square root of x. Now, I'm going to graph these real fast. Oops. Now I'll delete these. Okay, I'm going to zoom in. See if you can see this here. All right. So, first one we're going to do is 2x. All right. And then we're going to do the inverse, which was x divided by 2. I'm going to hit graph. That's the first one. That's 2x. And this is x over 2. Okay. So these are inverse graphs of one another. You know, an inverse graph, the original one's right here, coming up. The inverse is this one right here. An inverse function will always reflect over the line y equals x. So 1, 1, 2, 2, 3, 3, 4, 4, and so on. So you can see this graph is just basically flipped over that. Let's do one more real quick. We're going to do the x squared version. Okay. Let's graph this real fast so you guys can see what this looks like. That's the x squared. Now remember, we're going to flip over the y equals x line, which means that this guy is going to now look like that. And then this one is going to flip all the way down here and come down like this, okay? Because this line goes through here, and so it would flip. Let's see, I'm trying to use a marker that could stand out a little bit. Hold on, I got a better one. Let's see, I used to have a better one. I don't know where it went. Oh, that's, darn. Oh, there they are. Okay, let's see if this works. Okay, so here is the y equals x line. That's what our inverse is going to flip over. And then, so our new function, so this part is going to flip like that, okay? And then this guy here is going to flip over and look like that. So let's confirm that's true. Remember, this was square root of x. So there's the top half, but the bottom half didn't show up. Okay? Now, what you maybe have forgotten about graphs is that the vertical line test is way too far out. Okay, I'm gonna come back to this graph in a second, okay? So, we have a graph. If you have a question, it says, is this graph a function? Okay, now if you remember, back when IM1, IM2 maybe as well, a graph is a function if it passes the vertical line test. And this marker is dead. The vertical line test is that when we draw a line, every single line only touches the graph once. Now, I actually intended this graph to be a function, but I realized the way I drew it made it not a function. You see how it crossed right through here? Crosses 3 times. This is not a function. So it goes up, and it comes back on itself. A function has to have an x value, only goes to one place. Right now, let's say that, so let me use a different color. Let's say this was 1, 2, 3, 4, 5. Well, 5 right now, oh, actually, let's make this 5, where that graph crossed. Okay, ignore that blue line. This is 5. Well, 5 right now goes to 0. It goes to whatever value this is, and whatever value this is. So it's 3 different values for 5. So 1 input, 3 outputs. Not a function, okay? If we're looking at just a simple y equals x, that's a function. It passes the vertical line test. It only has 1 value all the way across. Well, what about that graph? That was what I was trying to draw on here with the yellow, the square root of x. So this one does not pass the vertical line test. Thus, this is not a function. Going back to our, oops, wrong button. There you go. Okay, we'll zoom back in real quick. Okay. So the reason why this part did not pop in is because if it were there, it would make all this not a function because it would fail that vertical line test. Okay. You also can't have a negative square root or a negative. You can't take a square root of a negative number. So with this being said, you also need to look at, well, this is going to come into play in the next, not this assignment, but the next assignment, when they ask you to look at a function. So let's look at only x squared. Well, it passes the vertical line test, right? So this is a function. If it asks you the question, what is the function, or is this function invertible? Well, it actually is not, because it fails the horizontal test. The horizontal test tells us if the inverse function is a function. And the whole thing would not be, because it fails the horizontal test. Sorry, lost the word. However, all the positive numbers from here to here, it would be a function. Okay? So if we were to eliminate the negative numbers, then the inverse function of this would be a function. All right? So there's a lot there. I don't expect you to memorize everything, but hopefully a lot of that was actually a review. All right, so let's go into the first question. Where are we at here? Okay. Determine if a function is invertible. Let's go. All right, here we go. So remember, x values can only go to one place. If an x value goes to 2 places, then it is not a function. So up here, here's our x values, a, b, c, d, e. Okay? Doesn't matter what we put in. They're just saying that whatever a is, it comes out 11. Whatever b is, it's 15. Whatever c is, it's 9. Whatever d is, it's 13. And whatever e is, it's 7. So first thing they want you to do is actually assign these. So a goes to 11. B goes to 15. Okay? So domain is your x values. Range is your output, your y values. C goes to 9. D goes to 13. And finally, E goes to 7. Okay. So that's the answer up here. Now we have to see if it is invertible. Well, you can see that all of our inputs. So the answer is yes, it is invertible. Now, if like C went to both 9 and 11, then no, it would not be invertible. Or any of them, for example. Waiting. There it goes. And it's right. Okay, next question. All right, so A goes to 1, B2, C2, D3, E4. Okay, so, yeah, so I got interrupted. So A goes to 1, B2, C2, D3, E4. So let's line those all up. So A goes to 1, B to 2, C to 2, okay. D goes to 3, and E goes to 4. Now, this, we have two numbers going to the same place. So, is this function invertible? Well, this is a function. I actually believe I said something slightly incorrect earlier, now I think about it. So this is a function because all of our numbers go to one place. But the invertible function is we're looking at this side and seeing where these numbers go to. Well, 2 goes to both C and B, which means that this is not, the invertible function is not a function. So no, it is not invertible because C and B go to the same place. So this is a function, but the inverse is not a function. Next one. All right, A1, B2, C4, D, D8, E16. So we can look here. These all go to one place. There's no duplicates, and it's all in order. So this is actually pretty easy. So in order of highest to lowest. So this looks like it's invertible. This is a function, and this is a function, or the inverse is a inverse go to one place. They don't go to two places. So yes. And finally, what we can see right now, if you look at the table only, A goes to 2, and E goes to 2, which means the inverse, 2 goes to A and E. 1 goes to B and D. No, this is not invertible. And then let's just assign the numbers. So A goes to 2, so does E. B and D go to 1, and C goes to 0. And there we are. And we're done.